going on out there? Surprise, motherfuckers. This is a surprise stream that I have made no preparations for and no planning, and I got a late start, so I only have like around a half hour, a little longer than that. So it was really almost a waste of time, but when have I ever planned anything properly ever? I don't even know if this is working. And I never even opened the chat, so if you are chatting out there, I will figure that out. Like, this is a fucking miracle I have even more than one subscriber with this fucking thing, because I don't know what I'm ever doing. I never do this right. I don't even know how. There it is. Hold on. I think I found it. I think I found the fucking chat. There it is. There it is. I found it. Oh, God. What the hell's wrong with me? Alright, can I close this? I can. Alright. Let's pretend none of this happened. Okay. Well, anyway, the chat's on the thing until questions at the end. So, I got this game. It's coming out early August on Steam. It's already out on the Mac App Store, but really kind of focusing on Steam because I feel like that's going to be where gamers go. I hate that word gamer. I'm never saying that word again. But that's going to be a place. So most of you guys are here for, because you're into programming and game programming. So what I thought I would do is kind of take a quick dive through the game code base, because I know some of you have been interested in how it works. And then I'm gonna kind of talk briefly on architecture, maybe some of the differences between the last time I made a game and now, and some of the changes and the reasoning behind them, or maybe the not reasoning behind them. And then at the end, if any of you guys have any questions or whatever, I'll be happy to take them and go to pertinent sections of the code to answer your questions. I got a really late start on this. I was hoping to start like a fucking half hour ago, and I got to leave at 1, so I think I should just get right to it. So this is not Unity, it's not Unreal, as most of you guys know. This is a 100% custom game on a 100% custom game engine, so everything here is you could basically say from scratch. I am not using OpenGL, which is the first time I've ever shipped a product not running on OpenGL, which is kind of a little scary, but I've also done a lot of testing and I feel really confident with my current rendering system, which is built on top of Vulkan, which is the successor to OpenGL. So it's much lower level, but it's also, one of those things where you no longer have to be at the mercy of how a driver is implemented. The way you program something on Vulkan is going to be exactly the same on every system that supports it, which is really good for people like me. They get frustrated when there's little minor differences between where you're running your game code. So let's get into the actual game code here and how it works. So at the highest level, what I have is the main function, which you guys should probably be pretty familiar with if you've been watching the videos on here. A couple command line switches, which allow me to specify certain things for how the game's going to work, mostly for testing. And then I create an instance of my GameLoop class, which I'm probably going to go into next. And then I run the game, which basically this entire function right here runs the entire game event loop or game loop. And then when everything's done, I quit. This junk here you can think of as just necessary crap to get the networking layer to work on Windows, which is WinSock. It's an implementation of networking sockets on Windows, so I won't worry too much about that. So the highest level, what do we have? We have a fucking game loop. This should be very familiar to people that have watched the videos as well. So basically, much like all the games I've done in the past, my game loop is an implementation or a subclass of my engine system class, which allows me to hook in various events from my VGL engine into any specific application that wants to use it. I'm not going to go too big into the VGL internals in this video. I'm going to stick mostly to the high-level game code if that's possible. But because I didn't plan this at all, who knows where it's going to fucking take us, right? You got to have your protein if you want to be a game developer. No, you don't. I don't know why I said that. Anyway. So the way the game loop works is it takes a couple startup settings, which we saw coming in from main. It will run a loop until the game decides to quit, and then it will do the, I guess you could say, the classic process for the way a game loop works. So let's just jump straight to that, actually. You know, we got your input, process, output. So the input is going to be the processing events, which are inputs that can come either from the operating system, like the window's been resized, the window's been closed, the keyboard's been pressed, the controller button on the PS4 controller has moved around, you know? Sorry, I'm just fucking with the fact that okay, there we go. So yeah, that could have happened. Any possible input that can come from the outside world, with the exception of networking inputs, which are a little weird, are in this function. Update is where the logic or the processing of the game that happens per frame is ran. This is where all the collision detection is done. This is where all the AI is updated. Anything that should happen and kind of propagate. Another way to think of it is you got the current state of the game, and you want to you take that as a given, and you want to compute the next state of the game. So it's like this differential that happens each frame. So if a guy is walking, you want to take note of where he is and where he's going, and then make that change one frame at a time, kind of like a flip book animation, like a Disney movie or something like that. And then you got your output, which will render the screen and draw the screen. As you guys know, games are rendered one frame at a time, and the way it works is you'll paint the entire screen, draw everything and render everything that's supposed to occur on one frame of the screen, and you use the current state of the game to render that, and then you will throw that away and start over immediately. Hey Saeed, I hope I said your name right. I love C. I was just talking about this with my buddies the other day, or my coworkers for one of my clients. C is a language that has not changed much in the last 30 years, and for that reason it's beautifully simplistic. But when you start writing more complex code, or a game like this that's edging upwards around 25,000 lines of code, you want to have a little bit more Swiss Army knife utilities, things that make things a little easier on you. So when you write higher level code, languages like C++ start to become a necessary evil. I write C for smaller projects and for things that are more academic and fun. And I just love to teach it because it's so much easier to teach. But when it comes time to make larger projects, and this game would definitely qualify, then I move over to C++ for sure. So this is the entire game loop. Basically, everything here is done. Like when you're running this game, when the game is running, you're inside some offshoot or some call of this function, which is really cool because at the highest level, this game is like really simplistic, and then of course, the devil is in the details. So let's look at the initialization, because that's probably going to be the one thing that's asked about the most. These are just some utility functions up here. I really don't want to get stuck in the reads on these. So the way this works is you guys have seen this channel a lot, so a lot of this stuff should look familiar. That's not specific to my game engine. I initialize SDL. You'll notice I initialize the video, the timer, game controller APIs, which I haven't gone over too much. Those let you talk to things like the PS4. Haptics lets you do Rumble, which I haven't implemented, but I maybe might want to in a future update. And then audio, which allows the subsystem for audio to go. And then SDL images initialized as well, but in this game, the only file formats I load, I believe, are PNGs. I use Mix Open Audio, which gets me access to the sound software sound mixer, which allows me to play more than one sound at once. I read some settings from a game settings class, which on Windows reads from the registry, and on Mac uses something called user defaults. This allows me to save the player's game setting preferences to the disk and back. After that, I create a window. This is where you guys will notice a big difference. I do not create an SDL renderer. SDL renderer is a very high level, nice 2D rendering system, but it does not help you with 3D, and it is rather limited when you want to do any kind of 3D game programming. So instead what I do is I take that window, I set up a Vulkan instance on it. It would be like, if I get into the intricacies of exactly how to do Vulkan rendering, we would probably have like a 50 video series. So I'm going to kind of not talk about Vulkan too much right now and just say that it is a replacement for OpenGL. I've implemented all the features to get parity, or to have the same feature set that OpenGL gave me, but I implemented it myself. And anybody who knows OpenGL or is familiar with that kind of stuff will not see a big difference there. But I don't want to harp too much on that right now because, again, this is like an hour-long video. Thanks, Saeed. That's really cool. Yeah, that's the reason why I made this channel, is to give people a leg up to learn how to make games. And starting with 2D is definitely a good way to get started. So after that, I initialize the controllers. I read some of those in. I set up what's called a texture loader, which is different depending on which OS I'm on. On Mac, I read directly from the Cocoa texture loading system for reasons that are kind of cryptic and not really worth going into. And on every other operating system, including Windows, I just use STL image to load the textures in as they're needed by the engine. Then I draw something. I use my engine to paint a black screen so that while the game is loading, you don't see a clear window, which used to happen. I don't know if it still does in some operating systems. But this code right here basically tells it to just clear the entire screen to black and don't do jack shit until everything's ready. Then we get into some of the cool architectural things in my game. I have these high-level manager classes, which kind of handle all the stuff that the game might need. This game is not overly complicated. It's not Grand Theft Auto 5, so I don't need to go super nuts and over-architect my asset solutions. I can use a very simple demand-driven asset system where I can either load things on demand or load them all at once. They can all fit in RAM anyway. And I found for this game, I saw that architecture was good enough, and I've been sticking with that since. So I basically read in the assets the game needs in the asset manager. I read in the shaders, or I compile the shaders, which are the 3D shaders that the game needs to run. I load in any 3D or 2D geometry and generate those, and then I load in all the sounds, and I load in all the fonts, and I do all that in these 5 lines of code, or 6, or whatever, I can't count. Then I create shadow passes, which are off-screen frame buffers that are used to do shadowing, which is a big topic that I might not get too much into right now. This is a high-level code dive, but I can maybe talk in 1 or 2 of these concepts at the end of the video if you guys are interested. And if you guys are really interested in any specific one of these topics, just let me know in the comments, or if you happen to miss this video when it was live, and maybe it can inspire the next video topic. This code right here just generates a timer which is ran every second, and this allows me to do things like count frames per second and do other auto rating things that this game might need to run. After that, if it's the very first time you play the game, I start the tutorial, which I'll leave as something fun for people that have actually bought the game to play. I actually think it's a really fun tutorial. And otherwise, I go straight into the TitleGameLoop, which goes into the higher level architecture of how this entire game works. So let's talk about that, right? After I have some protein drink first. Oh man. Okay. Sometimes I wonder like why I even do these, you know, it's like, I don't know what's wrong with me. Okay. I'm just thinking like, could relax on the Saturday, you know, instead I just decide to start streaming instead. Well, I'm glad I do this though. This is fun. And also, like, I worked so hard on this game, I kind of want to show it off, you know. But I digress. So what I was talking about, high-level architecture. So the way this game works, you guys might remember in the past when I made a game like 5 years ago, I had the concept of GameStateRunner, which I kept around, but I kind of changed the way it worked a little bit, in the sense that instead of having game state runners, I call them game loops. And you can think of them as kind of like sub loops. So the game is still a state-based machine, meaning it can switch into different modes depending on what section of the game you're in. And at any given point, only one of these game loops or game state runners or game states are active at a time. So for example, you could be in the title screen, or you could be in the battle mode, or you can be in the strategy mode, or you can be in the tutorial mode, which I believe is also handled by a subclass of the battle game loop. So when the game starts out, I tell it to initialize the title game loop with make unique is it's like calling new, but it's with a smart pointer. It's some C++ syntactical stuff. But basically what this allows me to do is create one instance of the title game loop, pass a reference back to the game loop as its parent, and then set the current game state equal to a pointer of that title game loop. So the current game state is switched. It's a pointer to one of these objects, assuming that none of them are null. This is what dictates what current mode you're in. So you'll see throughout the game code in different areas of the game, I will switch the current game state to different states, and then when I do that, I'll switch. I also have a utility function called fade transition, and what this does is fades the game to black before it runs a function which is passed as an argument and then fades back from black. So what this allows me to do is at any given point in the game I could fade to black, run a function, fade back, and typically what I'll use this function for is to transition from the title screen to the battle, from the battle to the strategy mode. It's just a way for me to do it without a sudden change occurring, which would make the game look really hacked and kind of ugly. So for example, this transition to battle function, regardless of what state you're currently in, we'll call fade transition. This might look a little bit JavaScript-y to people that know that language, but this allows me to basically embed the result of what's going to happen when this fade transition is done directly in the calling part. And I always speak so confusing. It's a miracle you guys can understand what the hell I ever say. Okay, let's try to explain that again. Basically, I call fade transition, and then when the fade transition is done, or when it's black, it calls this code, and then it fades back. And you'll see, like I was explaining before, I set one of the game loops equal to a constructor call, which creates it. I prepare some other things, and then I set the current game state equal to that game loop, and that works. The reason why this works is because the current game state is a pointer to GameStateRunner, which is an abstract base class that can be pointed or set to any implementation of GameStateRunner. So this thing doesn't know, I went to the wrong place. This thing doesn't know exactly what type of GameStateRunner it is. All it knows is it's a GameStateRunner. So every game state will implement these functions. From my C++ tutorial video, this should look a little familiar to you guys. These virtual functions can be implemented by any type of game state that I decide to implement in the future. So I basically, every game state has its own process, update, render. It knows how to draw itself. It knows how to handle keyboard and controller events. It knows how to update itself. But from the high level code, all that really is happening here is when I call process events from the parent game loop, I have a bunch of stuff in here that handles keyboard events and stuff like that at the highest level. But you'll see at some point the current game state will also call process events. When I call update, this is some online networking stuff I'm not going to get too far into right now. This processes the fade I was talking about. But you'll see if there is a current game state, I call update on every parent game loop update. And with the render, same exact deal. If there's a scene which is set at the highest level, a 3D scene, I render that directly from the parent game loop. But anything that's specific to the game state is rendered directly after the scene. So what this GameStateRunner allows me to do is specify a contract of exactly the way every single game state runner or mode will behave. And then I have some utility functions in here that might be common to all game states. For example, do I want to show an alert on the screen? Do I want to show a yes/no prompt that passes back a handler when the user hits yes or no? Do I want to handle things like scheduling tasks, which are functions that are called after so many seconds or frames elapse? And I have the implementation of those utility functions in the GameStateRunner. But from the highest level perspective, you really don't know much about how a GameStateRunner is going to operate. So I'm going to fire up the game here for a second. I'm sorry if I'm saying your name wrong, Paulo. Nice to see you. 11 years old. Wow, you're starting before I did. I wasn't even 14 until I learned C. So that's really cool, man. I'm really glad to read that. I'm getting a real head start. You're going to go far. Okay, so let's run the game and show... Fucking someone sent me an email. We're going to run the game. So this is the title. We went to the title, and now the title's doing its thing. And then we can go into a skirmish. Transition. Now we're in the battle game state. And now we're in the skirmish. And now we got the AI trying to kill me. I got debugging I can turn on. So, what in the hell has all just completely happened? Well, if you go into the title game state, TitleGameLoop, you'll see that TitleGameLoop is an implementation of GameStateRunner. It implements process events, update, and render. It knows how to initialize itself, which it does. It calls some utility functions to generate things like text labels, which are implemented very similar to the way I did in my C tutorial series using free type, I think. True type fonts? Well, maybe it is a little bit different, but the end concept is the same. I'm able to draw text on the screen. So yeah, it'll initialize itself. It knows how to create menus. It knows how to update itself based off of what's going on. Now the title doesn't do all that much, so there really isn't that much inside this update besides maybe fading in and fading in the title. Not the whole screen, but just that logo you saw fade in. And I intentionally stagger the fade in to make it kind of look more like Metroid, more like an NES game, which is a stylistic choice. Moving on, render is not too complicated at a high level, but again, this is implementation of how the title is rendered. So I do some OpenGL-like things to do things like setting the ortho projection matrix, which is a way of telling it to do 2D projections using 3D graphics hardware, which is kind of a bit of a subject, but it's basically telling it to how to draw 2D graphics on the screen. I have some utility functions in here which will render the title and render the UI, which are like the menus and stuff like that. So that's how the title is functioning at a high level. I have this menu class, which is a whole big thing I could go into, but this allows me to really easily define menu items and how to handle the user selecting those menu items when they are selected, and then how to go into sub-menus and stuff like that. This is, I don't want to say some of the more boring aspect of the game programming, but I'm sure you guys don't want me to spend too long. Johnny, save that question. I'll definitely, that'll be one of the first ones I address when we get to the Q&A. But yeah, the title is not all that interesting. Probably the most interesting part is when it's time for me to go into the skirmish, as you guys saw when I went into that part of the menu. Right? So this is that menu we were just in, which is the skirmish menu. When we say that we want to do a skirmish, we land in this function which calls transition to battle that I was showing you guys earlier. It sets up a couple things about how the game battle is going to work, you know, how many types of each unit you have, and then it calls transition to battle, and then this is called when the battle is finished, when we transition back from the battle. Which in this case, Julie would just take us back to the title screen. So transition to battle, I'm going to go back to this and show you guys how this works. Fade transition, create a battle game loop, change the sky gradient, which is what I use to draw that background gradient, and then we should have transition from battle, which is called whenever the battle is done, and this will either take you back to the strategy game loop, which I haven't shown, I might not get to today, or the title game loop if we were coming from the title. So let's go into the battle real quick because I want to show you a little bit about how the game objects work. This is a pretty big one. So again, implementation of GameStateRunner, except this time it's the battle game loop. We have a constructor which will initialize it. We have our three functions that we would expect to see here. Process, update, render, which are more complex for a battle for sure. We have some other interesting things in here. We have the first mention of something called GameObject, which is my high-level base class for all game objects in the entire game, or at least ones that are somewhat interactive and drawable. So this class is a thing. Do I go into this first? Let's go into the battle game loop at a high level first. So when we go into the battle, we load a scene. These scenes are made in Verdo Studio, and let me see if I can quickly show one here. I haven't gone too much into assets. So these are using my engine to read in files that I've made with Verdo Studio that have various different properties and things set to make sure that the game will work. Really don't know what else to say about this except that they're here, they're loaded in, and they use my engine to draw themselves. So this is some of the convenience factor of kind of how I chose to handle 3D asset loading inside my engine. So I load one of these scenes in when the game starts. I call optimize, which doesn't do too much anymore, but it just makes it so that Vulkan, it optimizes the scene for whatever current operating system and graphics API I'm running on. I add shadow mapping to the scene. I set up some lighting things. I set up unit positions. I set up the camera, which is that thing that controls where you're looking at in the game. Because you guys may or may not have noticed, I have 2D sprites running in a 3D world. So I'm very careful with the camera, and I use some shader tricks called billboarding to make sure that those 2D sprites always appear upright regardless of how the camera is looking at them. So I don't move the camera too much to keep that illusion in place. That was a stylistic choice as well. Kind of a throwback to the way old PlayStation games used to work when they didn't have enough horsepower to drive 3D assets in 3D worlds, so they would use 2D sprites. I did it because I'm one person and it can take a really long time to do 3D artwork, especially for characters, and I didn't want this game to turn into like a year-long project. Plus, I just think sprites look cool. I mean, who doesn't? If I actually were to go into the sprites, you guys would see very similar techniques to other videos I've done in the past. These are just sprite atlases or texture atlases. So there isn't a whole much here that I can go into besides some of the more Vulkan, OpenGL, CGI rendering tricks that I do to make this stuff as efficient as possible. I likely won't get down to that level today in this video. So for general purposes, you can just know that I'm using sprite atlasing. I built some collision detection boundaries, which are actually taken directly from the Verto file. So if I were to open this file back up, you'll see that there are some hidden objects. I'm supposed to fucking be. Hold on, allow. There are some hidden cubes that I have intentionally hidden so they don't render. But I use them for collision detection because being a programmer is about just being as optimal as possible, and it would be really dumb to detect collision against models that might have tens of thousands of polygons. You only want to look against the cube. So that was the idea behind that. And I retrieve these cubes at runtime and use them for collision detection. So that's what that is for. So let's talk about the game objects. Yeah, let's talk about the game objects, and that'll probably be the end of the code dive, and then I'll start taking some questions. So, game objects. The game objects span across different modes of this game, including the strategy mode, which is that board game mode with the hex tiles, which I really did want to go into today, but I probably won't have time. But I'll just say that that mode is heavily based off of the last live stream I did, where I was doing hex tile work. That literally segued into this game. So that work ended up being really useful because I had never done hex tiles before this year. But anyway, sorry, I keep going on tangents. The way the battle objects work is that every object in the game that is drawable, animatable, subclasses from this game object base class. So every game object in the game is one of these is an implementation of this abstract base class. So the game object can be updated, rendered in 3D or rendered in 2D. It has a sprite, which is basically, or it may have a sprite. If it's a visual game object, it'll have a reference to one of the asset manager textures. These asset manager textures are like pointers into the asset manager to make it so that I don't have to keep copying and rereading instances of the same textures. I can just have a reference back to that one texture and use it for multiple game objects. The way I did that this time around was actually really neat. I used enums instead of just pointers, and then I have a mapping from, I'm supposed to have a bucket mapping. Oh yeah, I have a mapping from each enum to the actual engine texture. But so yeah, every game object has a sprite. It has the number of frames there might be in the sprite if it's animated, which is that texture atlas stuff I was talking about. It has the current frame index, so if it's animating, which current frame it's on in the animation, whether or not it's horizontally flipped, and so forth and so forth. There's a lot in here. There's the position of the sprite in 2D. There's the world position of the sprite in 3D, because I do all the collision detection and math in this game in 2D to keep it simple, but all the visualizations in 3D, which gets a little bit weird. Some people call it like a 2.5D game, which you could say might be accurate for this. So every single game object has this type of implementation for it. I also have a battle game object, which is a further narrowing down of that inheritance structure, or that abstraction. So every battle game object is a game object, but there are different types of battle game objects. As a matter of fact, I have them listed here. Most of them, soldiers, bullets, missiles, cannonballs, boundaries, drones, tanks, barn animals, explosions, bullets, everything in there, right? And every type of battle game object has some more specific things. For example, what player team are they on? What's their bounding box size? Are they on the bridge? Are they falling? Are they dying? Override implementation of specifically more how to render the battle game objects, which I believe, does this do anything? This doesn't do anything. The rendering is handled further down the subclass of this class. How to collision detect, because collision detection is only needed to be done in the battle. You don't need to do collision detection on the hex grid because there's nothing to collide with. So I only put that in the battle game object. So we're going to show you one instance of one of these battle objects. So here's a concrete subtype of one of these, soldier. Soldier is I got controllable battle game object. All this basically means is that you can control them with the controller. You can select them, and they can receive events for like moving or shooting or something like that. So controllable, real quick. Yeah, like I was saying, they can move, they can attack, they can kill, or they can be killed programmatically, so forth. They can. When you go into the game, I'll show you real quick. This was so big for me to try to dive into this in 1 hour. You'll see here that I'm able to select them up and down. That basically means they're control targeted, and then I'm taking control of them and I'm moving them. So that's what that means. So the soldier is a type of battle game object that can be controlled. They have specific functions for implementations for how they move, how they attack, how their collision detection works, and so forth. This is a very big file because there's a lot of shit in here. So I'll just quickly go through it just to give you one example of how this works. The implementation is very split across, because the whole point when you're doing game programming is you don't want to get one file that's too overwhelming. You want to split things up and keep things nice and organized. And that's one of the ways C++ helps you do that with the object-oriented programming. So for the soldier, we know that the object type is a soldier, how many rounds per magazine is initialized, some stuff about how to draw the shadow and the bounding size, which is really important. That's the size of his 2D bounding box. When it comes time to get sprite, to know which way to draw him, the sprite is dependent upon which team he's on, and then I just return which pertinent asset manager sprite is based off of which soldier is based off of his team color. Every soldier has 5 frames. Showing you that. Where are you? There it is. Right? 1, 2, 3, 4, and 5, right? So we have 5 frames. The current frame index is basically based off of whether or not he's walking or if he's dead, right? There's not too much onto that. I got my code for handle for moving. If I'm moving with the stick, the axis is passed as a 2D vector. So your XY of this analog stick will dictate this axis, which is a normalized vector. Which, if you guys don't know what vectors are, I have a vector video on my shader dev series, which might be worth a watch. And this allows me to specify the position offset based off of, the walk speed of the character, the amount of time that's elapsed between frames in the game, which is a whole concept I could go into in another video, which is a little bit more advanced form of auto rating based off of frames per second. And then the axis, which again is passed in, and that's the direction on the analog stick. I have some code in here to handle the bullet firing, which should be similar but not exactly similar to that video that I had that probably has more views than all my other ones, which handles the machine gun firing. And then I have some code in here to handle like whether he's falling into a pond or whether he's falling off of a cliff. Rendering for the battle soldier is handled by basically the higher level BattleGameLoop class. which is something that you guys are probably interested in, but I'll probably talk about that last. And then collision detection here is a whole big thing handled by the boundary class. This is very similar to the more recent video I did on how to do collision detection, so I would look at that video and take a look at that if you want to see how that works. It's even more simple than that though, because this one's in 2D and not 3D. At least I believe it is. So now that we've looked at how the soldier looks and how the soldier works, you can see when it comes time for the actual battle game loop to initialize, I should have something here that says set up battle positions. I have a function which will actually create each type of unit. So you see here is where I actually create one of the soldiers. I place him into a unit, which is a object that treats many characters as one, so that when you move them on the stick, they all move together. So I kind of have an encapsulation of a battle unit, which the soldier goes into as a member. Probably won't be able to get to that too much today. But the key part here is the game objects array is the array of every game object in the entire battle simulation. So I have an array of pointers to game object or battle game objects, and these are all the game objects in the entire battle game loop. So when you see me add game objects dot in place back, I'm pushing to the back of the game objects array every object I'm creating. And the reason why that's important is when you look at something like update, you'll see I iterate through every game object and call update on the game object. And then I do collision detection on every object in the game object. Then I do some Z sorting and some weird things. And if anybody's been destroyed or is dead, I essentially clear them out and delete them from the game objects array. So I update them. What the hell is this called? Process events. Oh, that's right. There's a player class which handles updating for that. I'll have to look at that in a second. I call render on every game object. And you'll see something really interesting here, and this will probably be one of the last things I talk about. I handle purposely all the rendering of every single 2D sprite in the entire game in one shot, and I do that for efficiency. In other words, there's some tricks in lower level graphics programming called instanced rendering, or people that use Unity probably know it as draw call batching. And what this allows me to do is tell the GPU how to draw many different objects that have different sprite frames with one draw call. And when you start getting a ton of bullets on the screen, stuff like this starts becoming really important. So I basically have some functions here to handle sprite rendering for the entire 2D battle game loop, and that's called render sprite batches. And what I do is I sort all the game objects based off of their types, or what their sprite types are, and then I have one function which prepares a bunch of low-level shader parameters for how to render all the sprite batches for each specific type of game object, and then I do it. This is pretty low-level graphics programming, some advanced stuff in here. I'd love to go over this at some point in the future because I'm really proud of it, but it's probably too in-depth for kind of a architectural dive. But just know for now I'm doing draw call batching or instanced rendering, which is some pretty neat stuff. And the way this works is I have an array of game objects, and then the game object answer questions about things like their current sprite, their current position, information I can know on how to draw them without knowing exactly what type of object each individual object is. And that code is right here where I do that. So at the highest level, this will be the last function we talk about. The game draws the frame by clearing the screen, calling scene render, which renders the 3D scene, which is loaded from Verto, which I keep closing because I'm a genius. I meant that sarcastically. I don't know what the fuck I'm doing. And then I call GameStateRunner, which calls into here if you're in the battle game loop, which calls the rendering of the sprite batches. Any rendering that is per game object that is not fall into the category of sprite batching could be handled by the individual render function of an individual game object. If I'm debugging, I draw some obstacle grid stuff. If there's any 2D text on the screen, like that big 3, 2, 1, go you saw, I handle that here. and then that's the end of the drawing for battle. It's almost ridiculous how simple it looks, how much work it took me to do, and then I just go through it in a second. After that's done, I do more rendering. That might happen in any game state, and we're back in the high-level game loop class here. And in that case, there really isn't that much here. It's just overlay text. For example, I have some stuff where, like, if you're in a chat room and you send some chat, it'll pop up. Or if the controller's been disconnected, I notify you. Or if the frames per second is turned on by some debugging console, I draw that here, and then that. If there's some fading out, I draw a big black rectangle with semi-transparency over top of the entire game. That's implemented here to handle the fade to black. And that is the entire draw function. And I believe I've just taken you guys through at least a small piece of how this whole damn game works. Jesus. That was way more involved than I thought it would be. All right, I can take some questions now. Let me look and catch up on what's been sent in the chat. Not too much. I hope you're still here, Marazi. You said, am I using a game engine? I'm using my own game engine. So my game engine has been developed from scratch. I haven't gone into my game engine at all here. It's more of a graphics engine than a game engine, but I built that engine over years to support this 3D modeling program called Verto Studio. But I've been making some games on top of it every now and then, and this is a game that's been made on top of my engine. So I have another one from Psychotic93 Iffy. Sorry if I said your name wrong. You said you found my channel, C++'s favorite language. You were just wondering if I'm interested in competitive programming. I am not. I have a big opinion and issue with competitive game programming. Sorry, I'm sending it. Friend is supposed to be here by 1. I have an issue with competitive game programming. I feel like it's something that people do to measure egos. It's something that people do to feel cool. I don't see much value in it. I've known people that have done well in programming competitions that were really not good in industry, and I would never want. I don't want to generalize, but I'm saying people that need to be outwardly show that they're good at coding and be snarky about it usually aren't very good at it, actually. It's kind of like the people that are good at passing tests, but they don't actually, they're good at studying for things and getting good grades, but they don't know how to actually do the work. Maybe that's just all I'll say about that. If you want to get into competitive programming, that's fine. Just don't feel like that's going to translate to being a good programmer in the workforce or in industry. I would much rather value someone that came to me and showed me a big portfolio of open source or even closed source products that they've released and showed me this is my work, this is my portfolio. To me, that's more valuable than saying I got this award because I won a programming competition. So, yeah. I'm going to hang out for another like 2 to 5 minutes and see if you guys have any other questions about this code base or how this game works. And then I can dive into that stuff as well. I realize I probably just overwhelmed a lot of you guys. I didn't mean to go into so much of this detail, but it's really hard to talk about this game at a high level. At least I hit on the main points I wanted to, which was like the GameStateRunner itself, the abstraction there, and then the game object abstraction. I guess I can at least show you this one. I'm waiting if there's anybody else has any other questions. Okay. We have another game mode I didn't really talk about, but you've probably seen in the video, which is called Campaign. And what Campaign is basically it's a grid-based, a hex grid-based, turn-based mode, which allows players to move their units around. And the idea here is that if you invade somebody else, that goes into the battle mode, and you need to win all your little battles to win the entire war. This whole mode was a whole big thing that was really interesting to get into, and I really enjoyed programming. And in my code, it's called the strategy game loop, I believe. Yes. I don't know why I call it that. I always have really stupid names for what things actually are. And this has a whole big ecosystem around it as well. Basically, game objects array, but this time we have strategy game object instead of battle game object, and you got subclasses of, hold on one second here, I'm going to turn off this banner, I don't have it anymore. Yeah, so you got strategy game objects, which are different types of game objects, but they answer questions about where they are in like the 2D map and stuff like that, which is really neat. And I got the hex map itself, which I believe is a type of game object as well, so things got really kind of neat with the architecture around that. What's really fun about that hex map, though, is that I didn't know at all how to do hex map coding until I did that last live stream where I was doing a C coding live stream where I was doing that. So if you actually look at my maps here and open one of them up, you'll see go over here. I actually used the exact same file format that I came up with during that other live stream, which was pretty nuts, and I was able to actually, it's kind of silly and not really good for like production game programming because you got to like get all this right with text editor, but being able to reuse that work was really cool, and that's one of the reasons why there's no wasted work when you're learning something with coding. You can always find a way to take some knowledge that you got from one aspect of something you've been doing and leverage it and reuse it somewhere else. And that was definitely true when I made this strategy hex map. Right? It was literally pasting in code from that C work and bringing it into this game, and it saved me probably like another 2 days of work when I was making this thing. So that was pretty awesome. So if there aren't too many other questions, I'm probably going to call it here in a sec. This was a really